Hi everyone, in this video I'm going to be discussing physical properties, or properties of matter that can be observed or measured without changing the composition of the particles. This is an important distinction because later on in the year we're going to be talking about chemical properties, which will start changing the chemical bonds between atoms of a particular substance. So when we're talking about physical properties, we're only looking for things that can either be observed or measured that don't change the particles themselves. So over here I've got a pile of table salt, or sodium chloride, and I can very clearly see that sodium chloride is a solid. I can see that it's white. I see that it's made of small crystals. And I could get a little more creative and start to notice through some experimentation that the density of this particular solid at this particular temperature is equal to 2.16 grams per cubic centimeter. I could look a little further and see that it has a melting point of 528 Kelvin, or around 800 degrees Celsius. I could go further and say that it boils at 1140 Kelvin, or just over 1400 degrees Celsius. But all of these things can be observed or measured without changing the composition of the particles. The only thing that might change, say with this melting point, is the distance between particles, right? We know that in a solid, those Na and Cl atoms are packed closely together. Whereas when it melts, that solid salt now has particles that are spaced a little bit further apart. So when we're looking for possible physical properties to talk about, we've got lots of examples. We said NaCl was solid, so phase of matter is a distinct physical property. Color. We can't always talk necessarily about color, but if you can, it was a very valid physical property. Particle size. Density. We can measure that in a variety of ways. Melting and boiling points. And there's one other physical property that I'd like to bring up because sometimes it gets confused with a chemical property. I know that if I take that sodium chloride and I drop it in water, that sodium chloride will dissolve in the water. You may think that that's changing the composition of its particles, but we also know that if we boil away the water through boiling, evaporation, or a more formal distillation, that I'll be able to get that sodium chloride back in exactly the same state as it started. So when I dissolve something in water, that's actually a physical property describing its solubility or its ability to dissolve. And again, if we wanted to draw that out to show why it's a physical property, all we'll need to look at is what a particle diagram of something dissolving actually is. So if I have a sample of water, I know that when something is dissolved, it's formed a homogeneous mixture. So let's take those salt particles, represent them with purple dots. I know that they're just evenly mixed together with those water molecules. If I boil all that water away, I will be left with solid particles of salt. So that I can go back and forth between these two physical property because it can be observed without changing the composition of those original particles.